These are the solutions for Math 75, Exam 4. Okay, number 1, f of x is x cubed plus 3x squared. Use a sign chart to determine max and min. So the derivative is 3x squared plus 6x, set it equal to 0. 3x times x plus 2 equals 0, giving me x equals 0 or negative 2. Plug in 0, you get 0. Plug in negative 2 to the original, you get 4. Okay, f of negative 2 is negative 2 cubed is negative 8. Negative 2 squared is 4. 3 times 4 is 12, so 4. Sine chart, f prime is 3x, x plus 2. If you pick a number over here, it'll be positive. Something in between, like negative 1, it'll be negative. And something to the right of 0 will be positive. So that tells me negative 2, 4 is a max, 0, 0 is a min. Number 2, f of x is x squared minus 4. F prime is 2x. F double prime is 2. That's greater than 0. That tells me the graph is always concave up. Set 2x equal to 0. That means x is 0. 0, comma, negative 4. It's a minimum. No inflection points. Here's my graph. Number 3, x cubed plus 3x. The first derivative is 3x squared plus 3. That's always greater than 0. So that tells me the graph is always increasing. There's no max or min. F double prime is 6x. Set that equal to 0. X equals 0. 0, 0 is an inflection point, it turns out, because if the second derivative is 6x, if I pick a number that's negative, 6x is negative. If I pick a positive, then it'll be positive. Okay, so it's always increasing. First concave down, then after that concave up. Number 4, absolute max and min on a closed interval. That means you have to plug in the endpoints also. So f prime is 3x squared plus 2x plus 1, minus 1. Set that equal to 0. 3x minus 1, x plus 1 equals 0. X is either 1/3 or negative 1. So I have to plug in 1/3, negative 1, negative 2, and 2. F of negative 2 comes out to be negative 1 if you plug it in. F of 1/3 comes out to be 22 over 27. There's all the work for that. F of negative 1 comes out to be 2. You work it all out. Okay. Oh, I forgot f of 2. F of 2 comes out to be 11. Okay, just plug back into the original. Okay, so from that list, the lowest number was this one. So the absolute minimum is negative 2, negative 1. Absolute maximum is at 2, 11. Number 5, the minimizing average cost. Average cost means take the original cost function and divide it by x. So 50 over x plus 10 plus 0.05x. And we're trying to minimize this quantity. And when you take a derivative, treat this as 50x to the negative 1. That's what I'm putting there. So C bar prime, average cost function, negative 50x to negative 2. Derivative of that is 0. Derivative of this is 0.05. C bar double prime is 100 x to the negative 3rd, or 100 over x cubed. That's greater than 0 for all x greater than 0. That means you'll have a minimum. The graph would be concave up, so at a horizontal tangent, you'd have a minimum. So I set C bar prime equal to 0. Set this thing equal to 0. Add 50 over x squared. Multiply by x squared. Divide by 0.05, you get 1,000. Take the square root, 31.62. Number 6, here's a profit function. So P prime is 2,000 minus 2x. P double prime is negative 2. That's less than 0, meaning concave down, meaning maximum. So I set this equal to 0, and that's pretty much it. So 2,000 minus 2x equals 0. Add 2x, divide by 2. X is 1,000. And then what is the maximum profit? I plug in 1,000 back in the original. It comes out to be $1 million. Okay, 7. The original function, you should multiply it out. That way you don't have to do the product rule. So multiplying it out gives me 100x minus x squared. So P prime is 100 minus 2x. P double prime is negative 2. That's less than 0. That means I'll have the maximum. Set the first derivative equal to 0. 100 minus 2x equals 0. Move this over. 100 equals 2x. X equals 50. Okay. And that's 50 trees per acre. That's how many trees per acre would maximize the profit. That's all the question asks for. Number 8, treat the square root as raising to the 1/2 power, as we know. So f prime is 1/2 x squared minus 4 to the negative a half times the derivative of the inside, which is 2x. 2 cancels the half. X is on top, square root of x squared minus 4 in the denominator. Number 9, x e to the x at x equals 0. When you plug in 0, you get 0, so you're at the origin. F prime, first times derivative of the second, x e to the x, plus second function e to the x times the derivative of the first, which is 1. Plug in 0, that gives me 0, e to the 0 is 1. So the slope is 1. So plug it into the point slope form, y minus y1 equals m times x minus x1, or you can just say y equals x. Finally, the derivative of this quotient root, bottom times derivative of the top, 1 over x, minus the top, ln x, times the derivative of the bottom, which is 1, all over x squared, 1 minus ln x over x squared. All right, so these are solutions for exam 4.